Hi, Algebra 1. This is Monday, January 22nd. I want to make sure, if you did not get done with the quiz last week, make sure you come in and see me on one of your off periods so you can complete it, okay? I'm going to have it probably graded and in the grade book, but if you didn't get it done and there's a grade in there and you didn't get it done, please come in and see me to make sure. I'm going to be on page 231. 231. So at the very top, there's some blanks. It says a blank to a system of linear equations is two variables at a point that makes both inequalities true. So a solution goes in that little blank up there. Let's take a look at problem number 1. So we're changing our equal sign to the inequality sign, so the greater than or less than signs, okay? Here's two different linear equations, and they give us the point 5 comma negative 2. So we want to see if this makes a true or false statement. So I have an x and a y. I'm going to plug in for x and y. So this is going to give me 5 plus negative 2. Is that greater than 5? Well, if I combine those together, I get 3 is greater than 5. So this doesn't work. I mean, even if I plug it into the bottom one, it's fine. Let's take a look. Say negative 2 is less than or equal to negative 5 plus 4. Is negative 2 further to the left on the number line than negative 1? This is true, so this is yes. But because I have one of mine being no, this is not a solution. Number 2, again, we have the inequality. So we have 2x minus y is greater than or equal to 4. I have y is greater than 3x minus 8. I have the point 6 comma negative 1. Realize that I have the inequality signs here, so I'm looking for true or false statements. So I have x and y. So this is going to be 2 times 6, 2 times 6, which is 12, minus 1, which is positive 1. So is 13 greater than or equal to 4? This is yes. This works. Okay, I've tried on the other one, so I'm going to go negative 1. Is negative 1 greater than 6? 3 times 6 minus 8. Is negative 1 greater than 18 minus 8? Is negative 1 greater than 10? This is no. Okay, negative 1's not bigger. It's not further to the left on the number line. So this is also false, not a solution. I guess you don't have to put false, that you don't need that. Now we're going to start looking at when we are graphing these. So let me pull up my graph. Paste. Perfect. All right, we're going to be graphing with the inequalities. So I have y is less than 1 over 3x minus 5. And then I also have y is greater than or equal to negative 2x minus 4. Let's graph this like normal. My y-intercept is at 0, negative 5, which is down here. My slope is 1 over 3, so from that point I'm going to count up 1, right 3. Now, before I make my line, because I don't have an equal sign underneath here, this has an equal sign. See that little down here? That's an equal sign. This doesn't. This means that it's going to be a dotted line. Let's make it dotted. Yes, we will be checking to make sure you have them dotted. The next one, I have 0, negative 4. So 0, negative 4 is down here. My slope is negative 2 over 1. So from this point, I'm going to go down to right 1. Now, because I have this little equal sign here, it's a solid line. So a solid line. And this time, because we're graphing inequalities, we're not worrying about where the graphs actually cross. What we want to do is we want to think about, okay, let's talk about the point 0, 0. 0, 0 is on the right side of the purple and on the top side of the green. Agree? So this is going to be a test point. We want to see if I take 0, 0, which is an x and a y value, if I take 0, 0 and plug it into my equation, does it give me a true statement? So remember, this is the green one. So is 0 less than 1/3 times 0 minus 5? Is 0 less than negative 5? This is false. Remember, this is for the green line. So what I'm going to do is I'm going to shade underneath the green line. And it's this whole region down here that I'm going to shade underneath the green line. Okay, so right now, if we picked a point in this yellow region all the way down here, it would work in the green line. So if I picked 0 or negative or 0, negative 12, and I plugged it into my original y equals or 1/3 x minus 5, it would get a true statement. But we have to test the other line too, okay? Because remember, 0, 0 is on this side of our purple line. So let's take our 0, 0 and plug it in here. So I get 0 is greater than negative 2 times 0 minus 4 is 0 greater than or equal to negative 4. 0 is actually further to the right on the number line, so this makes a true statement. So this means I'm going to shade the side of the purple line that the 0, 0 is on. So I'm going to shade over here. And let's see if this happens. Oh, I want to change color. I'm going to change it to blue, see what happens. Oh, there we go. See how my blue turned to green down there? So this blue is the true statement, but you see that green's place down there where the two overlap each other? Where it turned to green, that's my solution. My solution lives in here, in that green region. So it's below the green and to the right of the purple. Okay, make sure, if you have any questions, make sure you ask me, okay? Let's go to the next page, page 232, and we're going to do some more graphing. Okay, so I have y is less than negative 3x plus 1, and then I have 6x plus 2y is less than or equal to 12. This first one, my y-intercept is at 0, 1, so let's go ahead and plot that. My slope is negative 3 over 1, so from that point I'm going to go down 3, right 1. Because I don't have the equal sign, this is going to be dotted, so make a dotted line connecting those points. Okay. The second problem, because the x and y are on the same side, we're going to go 0, blank, and blank, 0. So remember, that's an x value, so I'm going to cover that up. So 2 times what gives me 12? Well, it'd be 6. So I get 0, 6. So 0, 6 is up here. And then this is a y value, so I'm going to cover this up. So that's going to give me 6x equals 12. Divide each side by 6, so I get 2. 2, 0, which is here. Okay, because I have this little equal sign, this is a solid line between these. These might or might not be parallel. But let's pick a test point. Now, it seems that my red kind of goes right by there. So let's pick this as a test point. Let's pick this as 10, 0. Okay, 0, 0 is right here, but I can't really tell about the red because I didn't draw it really nicely. But 10, 0 is over here. So this is an x, this is a y value. This is going to become our test point. Let's plug it into our equation and see what happens. So my y value is going to be 0, is less than negative 3 times 10 plus 1. Is 0 less than negative 30 plus 1? Is 0 less than negative 29? No, negative 29 is further to the left, so this is false. That's false. Okay, so I'm going to shade the left side of my red line. My left side of my red line. So I'm going to shade over here. Okay. So that, if I picked a point over there in that yellow region, if I picked a point in this yellow region, it would give me a true statement for my red dotted line. Okay. All right, let's see what else happens here. I'm going to still take this point. I'm going to plug it in here. So I'm going to get 6 times 10 plus 2 times 0 is less than 12. So 60 is plus 2, or plus 0. Is that less than 12? That's also false. So I'm going to shade the other side of the green line. I'm going to shade the other side of the green line. So I'm going to shade here. See how I'm shading on the other side of it? But also on the other side of this is this yellow. And if I shade over the yellow, notice it turns to a green because, well, it's kind of an art lesson over here. If you combine blue and yellow together, you get green in the world of art. So do you see where our solution exists? It's the green area. So my solution is over in here. Any of these points in that green, if I plug them in, that would give me a true statement. I do have markers up front if you wanted to grab one. They're underneath the board and just borrow them for today when you're doing these. That's fine. All right, let's look at number 5. Number 5, we have y is greater than 1/2 x plus 5. And then I also have y is less than or equal to negative 3/4 x plus 2. All right, so I have a y-intercept at 0, 5. So that's up here. I have a slope of 1/2. So from here, I'm going to go up 1, right 2. Because I don't have the equal sign, this is going to be dotted. So our dotted line looks like this. Now my other equation, I have a y-intercept at 0, 2, which is right here. And I have a slope of negative 3/4. So from here, I'm going to go down 3, right 4. This is going to be a solid line because I have that equal sign. Looks like that. Now this one, I can go ahead and, let's go ahead and choose that 0, 0. Because 0, 0 is underneath the red, it's down here, and it's underneath the green down here. Okay, so I'm going to pick 0, 0 as my test point. This one worked nicely because I could definitely see 0, 0 was underneath. So I'll plug it in. 0 is greater than 1/2 times 0, which is 0, plus 5. Is 0 greater than 5? That's false. So for my green line, that means I need to shade above it. So down here, if I pick a point down here underneath my green line, it'll give me a false statement. If I pick a point that's above it, up here, that would give me a true statement as far as my green line goes, or my top equation. Okay, so now let's go back to and plug 0, 0 into this one. So I get 0 is less than or equal to negative 3/4 times 0 is 0, plus 2 is 0 less than 2. That's true. Okay, so for my red line, I want to shade the same side in which the 0, 0 is on. So down here is the same side where the 0, 0 is on. So if I shade here, oh, did we get a color change? I think we did. What's that color change mean? That color change means that's where my solution lives. So this is my solution. My solution is in this green. Last problem that we're going to go over for today is number 6. And they gave us 3 equations. Now the nice thing is 2 of them are very quick to graph. And let's put my paste. All right, so this is going to be a dotted line. Y equals 3. Count in the y direction, up 1, 2, 3, and we have a dotted line right here. Ooh, my thing is starting to goof up. Okay, let me pause this for a minute. Let's start this problem over. My screen started getting goofy. All right, so this is going to be a dotted line in the y direction of 3, so we'll go up 1, 2, 3, so it's a dotted line right here. There's our dotted line. So let's do the second one. This is going to be also dotted. So in the x direction, I count out 2, and this will be a vertical line. Okay. And then my last one, oh, I can't really see that's a -3. Okay, and this last one, we'll do in black, or I'll do in green. We have a y-intercept at 0, -3, which is down here. A slope of 2 over 3. So I'm going to go up 2, right 3. And this is also a dotted line because we don't have that, so let's try and make our dotted line the best we can. All right, I'm going to pick 0, 0. Let's pick a nice hot pink color to test this. So I'll pick our 0, 0. Let's plug it in. So is 0 less than 3? That's true. Okay, so let's think about this. This is going to be weird to graph, but we'll try and make it work. Actually, you know what I'm going to do is I am going to use this crayon. Okay, so our red line is true. So that means I'm going to shade all down here, and I'm not going to fully color it in. I'm just going to show you what I'm going to do real quick. So that works for the red. Then I'm going to try the same thing with this one. Is 0 greater than 2? That's false. So for my blue line, I'm going to shade the opposite side of the blue line. So let's bring up our crayon. We'll do a blue crayon. So we're going to shade over here. So right now, where the crisscross intersects between the red and the blue is the solution for the first two. Then let's take our 0, 0 and plug it into this one. So I get 0 is less than 2/3 times 0 is 0, 0 minus 3. Is 0 less than -3? That is false. So I'm going to shade the opposite side of the green line. Opposite side of the green line, which is down here. Down here. So the region that is here, I'm going to color this in the best I can. Down in here, this is where my solution lives. See this? Because the red, the green, and the blue all overlap each other. So this is where my solution is. Okay? Hopefully that'll help you out. What do you say we do page 233 and 234, and let's do 1 through 13 odd. 1 through 13 odd. Have a nice day. Ask me if you have any questions. Remember, if you owe me or need to finish that test, come talk to me, come see me on one of your off periods.